Now, greetings, fellow grade 12s. It is Mr. Hlajao here. Welcome to Back to Basics, right? So, what we are doing today, we are starting our topic on inverse functions, right? So, I know that we have done, your linear function, your parabola function, your hyperbola function, and also your exponential function, right? So, what we are going to be looking at basically, we are going to be looking at inverse functions, right? So I know most of you, when you hear the word inverse functions, you are probably thinking that there is going to be, some new introduction of a new graph that you've never seen, right? So now allow me to just introduce to you now, firstly, that the word inverse, right? By just beginning with the word inverse, it means the opposite altogether, right? So, which means now here we are going to be examining what is going to be the opposite of all our graphs, right? So, which means now even from here now, when you are thinking of opposite, think of this, right? Think of when you are having coordinates of x and y, right? So now it's basically now where you are having an opposite is basically when you are having now a newly defined point where now you are having your y and also your x as coordinates, right? Now, for an example, if let's say I give you this set of point, right? If let's say I can give you this set of point. If let's say for an example, I give you that you have three, you have six, you are having what? You have three, you have six, you have three, let's say you have four, let's say you have negative four and also two. Once again, right? Now, and say I want the inverse of these particular points. What is that you are going to do now from here? Which means now the first thing that you can do now from here, the inverse of this would be 6 and 3, and this would be 4 and 3, and this would be what? This will be 2 and what? And also your negative 4. Out again. So basically, that will be, the very, very basic understanding of our inverse. Out again, right? So now, which means now from here, which means what is it that you are thinking of when you think of inverse? We are saying this is where you switch, right? So this is basically where you're going to switch your X and your Y. Are we together, right? And now for us to have our inverse function, we are saying this is basically where it is reflected along our line X is equals to Y, right? I know probably this might not make sense now, but let me just give you something that is very much basic here, right? Now, for an example, think of this, right? Think of, let's say now I give you a straight line function. Let's say you are given y is equals to 3x plus what? Plus 6. Can you see this one, right? So basically now this is going to be what we know as our linear function, right? So if now I can come to you and say, look, I am looking for the inverse of this particular function. What is it then that you are going to do, right? Now, firstly, I want to introduce to you this symbol, right? So I have this symbol which is right? F to the power of negative 1. And this symbol, it is the one that represent, right? This is the one that represent an inverse altogether, right? So which means now, for an example, if this was our f of x, then the inverse of f of x will be then this one over here, right? But now let's just work with what I just gave you now. Let's say you are looking at such basic equation of our linear function where you are having what? Where you are having y is equals to, this is 3x plus 6, right? Now we want to do the inverse of this function. Now what will be this, right? So remember now, I said firstly, when you think of inverse, you must think of, right? You must think of values that have been switched, right? So which means now, firstly, the first thing that you do now, where there is x, you write y, right? Where there is x, you write y, and where there is y, you write x, right? Which means now from here, what is this going to be? Now, this is going to be x is equals to 3y plus 6 altogether, right? And now, after this, then you would want to make your y to be the subject of the formula altogether. And how will you then make your y to be the subject of the formula in here, for an example, right? So which means now making your y to be the subject of the formula here would be what? So this is basically where you would start by now saying this is same as what this is same as your x minus 6 is equals to 3y, right? And then after, what is it then that you're going to do? Then you're going to divide by 3 this side, you divide by 3 this side, you divide by 3 this other side. Oh, it's okay. So which means now your value of your y, or rather your function here would be what? Your y will be same as what? Your y will be same as x over 3 minus what? Minus 2, right? Isn't it so, right? Because negative 6 over 2, this is same as negative 2, right? So which means this will be the basic understanding of our inverse function, right? So now, let's say now I say, I want you to plot this, right? So let's say I am saying to you now, look, this is what you've written for inverse function. I want you to plot this. What is it then that you are going to do now? Obviously, remember when you are doing x intercept, you are going to look for x intercept and also y intercept firstly of the original function of f of x, and then now the newly defined what? The newly defined inverse function. Are we together? So what is it then that you're going to do, right? So which means, for an example, for your f of x, when you are looking for your what? Let's say you are looking for your x-intercept and also your y-intercept so that you can draw this graph. What is that you are going to do, right? We know that for x-intercept, you let y be equal to 0. So this is going to be same as 0 is equals to 3x plus 6. And then now this is same as negative 6 is equals to 3x. And then which means now the value of our x here will be same as negative 2 when you are dividing both sides, right? So which means now our x-intercept will be negative 2 and 0, right? And for our y-intercept for this function would be what? Will be y is equals to 3 into 0. This is plus 6, which means your y would be what? Will be 6, right? So which means the coordinate here will be what? Here. The coordinate here will be 0 and also what? And also 6. Right now, let's say now I am saying I am looking also to find out the same values, or rather the same intercept when it comes to our inverse functions, right? Now our inverse function then will be what? This would be 0 is equals to, this is same as 3, this is same as x, rather this is x over 3 minus 2, right? Then when I take this one this side, what this will be now, this will be a 0, or this will be 2 is equals to x over 3, and when you cross multiply, can you see that your x here is equals to 6? And now, which means this is 6 on 0. And then now if I do the other one, your y-intercept, can you see that your y-intercept in this case will be what? This will be y is equals to, what is this? Now this will be 0 over 3, right? Minus what? Minus 2. Or rather, this will be 1 over 2, 1 over 3 into 0 minus 2, which is going to be same as y is equals to what? Negative 2. Can you see that this now will be 0 and also what? And also negative 2, right? Now, and I want you to look at something here that is very important, right? Look at this, right? Now, I want you to look. Can you see that what you had here, right? Remember, I spoke of the inverse as values that are what? As when you are switching values, right? Now, I want you to compare and contrast now. Look at the x-intercept of your of your original straight line function, and look at now here, right? Come and look at now your what? Your y-intercept of this, right? Surely there's something that you can see here, right? Even if I can say also come over here, right? Even if you can start over here, now we are having 0 and 6. Look at this. This is what? This is same as what now? This is same as your, this is same as what? This is same as your 6 and also your 0. Now, I want you to look at something. Are you not seeing the values that have been switched in here, right? Are you not seeing where you had your value of your x, now you have it as your value of your y, where you had your value of your y, you're having it as your value of your x, right? So this is what we mean when we say inverse, right? Maybe let me try and draw this graph, right? So let's say now I try to draw this graph over here, the graph of these two functions, and see in terms of what is it then that I am going to have in here, right? All right. Now look, so we said if, let's say I want to sketch this function, let's say I want to sketch the function, we said this one, it's negative 2 and 0, right? So I am saying, let's say now my negative 2 for my function of my straight line function, we said this is negative 2, right? This is negative 2. And also 0, we said also it's 6 and 0, which means 6 and 0 is somewhere over here, right? So this is what this is same as your negative 2 and 0. And then this is going to be same as what? This is going to be same as 6 and 0. Now, if let's say I want to draw this function, look, can you see that this particular function will be something like this, right? So this function, if I draw it, this function would look something like this, right? And then now, there is one fundamental thing that I want us to understand. We cannot draw, right? We cannot draw a straight line, or rather, we cannot draw an inverse function without firstly drawing what? Without firstly drawing our line where these particular graphs are being reflected, which is the line of y is equals to x, right? And what is the line of y is equals? This is basically the line that cuts in the what? In the intercept. This is the line that cuts somewhere over here, right? That's okay. Let's say this line, it's the line that cuts over here. Are we fine, right? Can you see it cuts in there? Now, let's say for an example now I want to draw my inverse function, right? Can you see that my y-intercept in the inverse function was 6 and 0, right? So this was probably 6 is over here, right? 6 is over here. And then when I speak of negative 2 right now, remember it's 0 and negative 2, and negative 2 is going to be somewhere over here, right? Are we fine, right? Let me just maybe fix this particular point and say this is somewhere here, right? Now, and then if I want to draw this function, what is it then that I'm going to have now from here? So let's say I draw this function. This function will look something like this, right? This function would look something like this. Oh, it's okay, right? So this particular function would look something like this, right? Let's say now my 2 was over here. Let me just write this point, which means the accurate point will be somewhere over here, where this is negative 2, and also in 0, this is same as 6, and also in 0. Oh, it's okay. So now, what is this, right? So basically, this will be a basic understanding of what is our inverse function, right? And now, firstly, which means our inverse function is always reflected along the line, which is what? Y is equals to x. All right, again. So this is the very first thing that I want you to take note of when we look at our inverse functions, right? Now we are saying, for an example, now let's say we are having this function. Let's say you are having a function of now y is equals to, right? This was y is equals to negative 3x, right? And then now I say I am looking for an inverse function. What is it then that you're going to do now from here? Isn't it that firstly you're going to switch the values of x and y, right? So which means this is going to be same as x is equals to negative 3 y, right? And then after I've done this particular step, then I am going to make my y to be the subject of the formula, right? So which means this will be negative 3, this will be negative 3, which means therefore my y is same as x over 3, right? And then, yes, this is negative 3 also here, which means this is y is equals to x over 3. Right, again. So which means this will be my inverse function, right? So let's say I give you now, let's say I give you a parabola. Let's say I give you my x squared, right? My y is equals to x squared. And I say now I am looking for the inverse of this function, right? Now, what is it then that you are going to do now from here? Remember, we know that to find the inverse, you just switch the values, right? So which means this will be what? This will be same as your x is equals to now y squared, right? And how can I get rid of the y squared, right? How can I get rid of the y squared? Which means now from here, this will be what? Now here, I will just find out then now what will be my square root of this and what will be my square root of this. Remember, to remove a square, you must find the square root, right? So which means my y here will be what? Will be the square root of x in here. Are you fine, right? Even though now, when I come back to this one, right, there is something that I want us to understand in here, right? But let's just get more and more of these equations and learn how to write the inverse firstly before we can come to the parabola, right? So now, let's say now I give you this. Now, remember this was straight line, this is a parabola. Let's say now I give you a hyperbola where you're having y is equals to, this is same as 4 over, this is x minus 1. How can you find the inverse of this? Remember now I said you start by doing what? You start by switching values, right? So when you switch values, this is going to be same as x is equals to 4 over y minus 1, right? And then now what will happen thereafter? Then I would want to make my y to be the subject of the formula. And how can I do that, right? how can I make my y to be the subject of the formula? Then I take the 1 firstly here. This is going to be x plus 1 is equals to 4 over y. Are we fine? And then now, what else then now I am going to do now from here? Now I am going to multiply by what? I want to get rid of the denominator of y, right? I'm going to multiply by y everywhere now. I'm going to multiply by y everywhere. And when I multiply by y everywhere, what is it then that I'm going to have here? Right? So I want you to look at this. Can you see that this is going to be same as y into x plus 1 is equals to 4? Are we all fine, right? And then now, what is it then that I'm going to do, right? Remember this y here and here, they are going to cancel each other, right? And when you multiply the y here, it's going to be y into x plus 1, which is equals to 4. And then now, what is this going to be now? Which means my y, I am going to divide by x plus 1 here and divide by x plus 1 so that I can have my inverse here, right? So which means the inverse of this particular function, this will be same as what? This will be same as 4 over x plus 1. Are we together? Now, which means this will be the inverse of all of this particular function now. Are we together? So basically now, this is what we are going to have when we are looking at our inverse function. Are we together? Right? Maybe let me get more practical example now so that we're just looking at our straight line and then we are trying to understand what will be a function, right? Let me just make up my space here. All right. Now, let's say now I have this particular question here, right? Now, I know now that, this is something that you have never been exposed to, right? But let's look at in terms of how do we, work with such things. Remember here, we are still looking at our just basic straight line, right? Now, let's start here. Now, they are saying now from here, you are given that you're having f of x is equals to 2x subtract 7, right? Now, the first question here, we are saying now is f of x a function, and then explain your answer. Maybe I need to come back here and make you understand in terms of what is a function, right? So we are saying now a function, it is any other, it's any other graph that obeys, right? That obeys our vertical test line altogether, right? So, which means now for a function to be a function, we are saying for each and every x value, there is only one y value, right? So, which means it consists of the ratio of 1 is to what? Of 1 is to 1. Altogether, right? So, which means now from here, look, I mean, by just mere looking here, is this going to be a function, right? Now, if we are about to draw this, surely this will be what? This will be something that gives us a what? A straight line. And in our straight line, for each and every x value, there is one y value out here. So is this going to be a function? Yes, this will be a function. Maybe I will explain also after we've drawn this in terms of why am I saying this is a function. But yes, this is going to be a function because now this it satisfies the vertical test line. Out again, right? Which means this particular function now it satisfies what we call our vertical test line, right? Or if you don't want to say this, now you can say now for it, because this is a function because for each and every x value there's one y value, right? Now maybe let's come back, right? Now they are saying now from here, right? So they want us to find out in terms of what will be now our domain and also the range of this particular graph, right? So I mean typically now here we know that from here, if let's say we'd want to find out what is the range and also the domain, right? So we are saying, remember, when we speak of domain, we are saying this, we are saying for each and every x values, are we together? We are looking for where the graph is having all the possible x values. So this is going to be all the possible x values. And when we talk of range, here we are looking where we are having what? All possible y values. Okay. And then now from here, I want you to have an understanding that whenever you have a straight line, right? So the range and also the domain, right? The range and also the domain of your straight line graph, it is always like this, right? This is going to be where x is the element of real numbers, right? And also your domain is always going to be what, where y is the element of real numbers. Because remember, when you have just a straight line, whether it's landed in this position or in this particular position, right? Can you see that this particular line, they always have arrows here, which shows that this particular x and y values, they are continuous from what? From negative infinity to positive infinity. Are we together? Right? So which means now here the domain and also the range of your straight line function will always be where x is the element of real numbers and also where y is the element of real numbers. Right, again. Now let's maybe look at now our 2.3 now from here. Now they want us to determine what is going to be the equation of your inverse, right? Isn't it that we know that this f to the prime of -1 is going to be same as what? This represents inverse. And remember what I said when we speak of inverse. We said this is where your, let's say now we are having y is equals to 2x subtract 7, right? Now the inverse of this function will be what, right? Now firstly, you are going to start by switching the values of x and y, which means this is going to be where x is equals to 2, y subtract 7. And then when you are here, then you want to make your y to be the subject of the formula, right? So which means this is going to be x plus 7 is equals to 2y, right? Then here you are going to divide by 2 and here you are going to divide by 2, which means now your inverse function here will be same as 2 into x plus 7 over what? Over 2. Oh, it's okay. So, and then let's write it the same way as they wanted it, right? So instead of using our y now, we are going to use the what? The symbol that represents an inverse. And what is that symbol? This is same as the symbol that is like this. Are we okay, right? So this is f of, right? This is f to the power of -1x. Are we fine, right? So this is what represents the inverse. Now, what is it then that you're going to do now from here? So let's look at our 2.4. Let's say this particular question require us to draw now what is going to be f of x and also the inverse of that. Now, what is it that you're going to do to draw that, right? So we are going to start here. Now, to draw this particular function, now we will obviously need the value of your x and also the value of your y. And how can we then do that, right? So which means now we are going to firstly start by finding what is going to be your x intercept and also your y-intercept, right? So let's start with the original function, right? So which means this for x-intercept, this is same as 0 is equals to 2x subtract 7. Then you transpose the 7 this side, which means this is same as 2x. Then you divide by 2, which means your x here is 7 over 2. So which means the coordinate here is 7 over 2 and also and 0. Are we okay? Right? It's 7 over 2 and also 0. Now our y-intercept here will be y is equals to, right? Will be y is equals to, this is same as what now? This is same as your 2 into 0 subtract 7, and then which means your y it's same as -7. Right, okay. Now, by now, I would tell you now that, the opposite or the inverse functions of this point will be what? So can you see that what is going to be our x-intercept? If let's say you remember what we did in the beginning, right? So which means now from here, we are going to say, now we are going to have our y-intercept as 7 over 2 and also as our y-intercept at 0 and 7 over 2 for our inverse function. And this one we are going to have 0 and -7 here. And then the inverse of this will be -7 and 0, right? But maybe let me just write that. Let me just, calculate what will be then the inverses, right? The x and y intercept of our inverse function, right? What will this be? So which means now from here, if let's say I start here. So now if I'm looking for my inverse here, look, this is x plus 7, right? Let's say I'm looking for my x-intercept. Can you see that this is going to be 0 is equals to, this is x plus 7 over 2, right? And then what will this be? Right? This is, remember, this is over 2. And then what will this be for an example now from here? Now remember the over 2 here, it divides everything here, right? Or maybe now if I can start by separating, this is same as 0 is equals to x over 2. This is going to be plus, this is 7 over 2. Oh, it's again, right? This is something like this. And then now what is it then that you are going to have from here? So which means now we are going to transpose this one, which is same as -7 over 2 is equals to x over 2. And then when you cross multiply here, you are going to multiply by over 2 so that you cancel the what? So that you cancel the denominator of 2. So which means this is going to be 2 and 2, which means this 2 and this 2 are going to cancel. Can you see that these 2 and also these 2 are going to cancel, right? So which means your x is same as negative 7, right? So which means your x-intercept here, it's going to be same as negative 7 and 0. And then what will then be the y-intercept for an example, right? So the y-intercept now here will be same as what? Now remember we said this is y is equals to 0 plus 7 over what? Over 2. And then when you plug this in your calculator, this is same as y is equals to 7 over 2, which means the y-intercept now this is same as 0 and also 7 over 2. How it's get, right? Now, I want you to look at these coordinates and see whether, isn't this the same thing that I said, right? Can you see that now this for the straight line function, it was 0 and negative 7. But now for our inverse function, it's negative 7 and 0, right? Even if you can check here, this is 7 over 2, right? This is 7 over 2 and 0. And then what is it that you're having here? This you are having 0 over what? Over 7 over 2. Out again. So basically now this shows that now inverse is just the opposite of whatever that you are having, right? Maybe then let's try and draw these particular functions here, right? Let's try and draw these particular functions. Out again, right? I think by now we just remember these coordinates that what is that we had this other side. We had negative 7 and 0. We had what? We had also 7 over, or rather 0 and also, right? What is this? Oh, we had 7 over 2. Look at me now. Negative 7 is this one, right? So we had 0 and 7. We had 0 and negative 7. Yes, as the y-intercept. And then here they had what? They had 7 over 2 and also 0. Yes, that's what I'm trying to just write. So it was 7 over 2 and also 0. Now, if let's say we want to plot this function, what is it that you are going to have now? So this is us trying to plot here. Now, when we are plotting here, what is it then that you are going to have here? So now this is us plotting, right? This is us plotting. Now, so let's say now, remember, before we can start with anything, I said now, for us to draw any inverse function, this must be reflected within the line of what? Y is equals to x. And then the line y is equals to x, it always, intersect in the what? In the origin, right? Because this is the line which say y is equals to what? Which is equals to x. And this is the important line whenever we want to draw our inverse function. Are we fine? Now, what else then now are we going to do now from here? Let's see. So now from here, which means now I am going to come back here and say, what is this going to be? Let's start with the first one. The first one is that we are having 0 and negative 7, right? And 0 and negative 7 would probably be somewhere over here, right? If let's say I extend this, will be somewhere here where we are having negative 7 and 0. And then you are having what? You're having 7 over 2 and also 0. And what is 7 over 2 and 0 in here? This was negative. And 7 over 2 and 0. What is 7 over 2? 7 over 2, it's going to be what? 7 over 2 in decimals. I think this is 3,5 if I'm not mistaken, right? Yes, this is going to be 3,5. And 3,5x here, it's going to be found somewhere here. Are we all fine, right? So this is going to be same as what? This is going to be same as 7 over 2 and 0, right? Yes, this is 7 over 2. Let me just try and write it nicely here. So this is same as 7 over 2 and also what? And 0. Let's say now I want to plot this particular function. What is it then that I'm going to have here? I am just going to join this function of mine, right? It comes probably somewhere here. Let me maybe just use it nicely. Let me start probably somewhere here. So as this function starts here, it starts here, it continues, right? It continues somewhere, right? That's okay. Let's say this is something like this, right? Where this is 3,5, right? And then now, what is it then that I'm going to have from here? Now, after that, now what else then now I am going to have here? Then I am going to look at the other function. What is it that I had in the other function? Now, I had what? Now, in the other function, I had your, what now? I had my negative 7, right? My negative 7 here, it's somewhere here, right? Let me just extend maybe this, let's say my negative 7, it's somewhere here, negative 7. And then the other coordinate, what? It was negative 7 and 0 and also 7 over 2 and 0, right? and 7 over 2 is 3.5, which is somewhere here, right? So this is probably somewhere here, 3.5, right? And then now what is this going to be? Now, when I plot this particular function of mine, right? This function would look something like this, right? And now, maybe one thing that I need to fix, I need to ensure that this line of mine was drawn into correct scale, right? Even though this particular thing that I'm using here doesn't necessarily help me when I am drawing to scale, but I'm just going to try and ensure that this line, it is drawn into scale, right? Uh, Now, then when I want to plot now my other function, what is it that I'm going to have in here, right? So this particular function will be something like this, right? So this function will be something like this, where there is some form of intersection between these two functions, and it intersects somewhere like this. Are you all fine, right? So basically now, this is going to be just an idea of what is it, right? What is it then that we are going to use, or rather, how our inverse function look like, right? So I think by now you can see that this is just the opposite of the other function. It's not necessarily something that is new, right? And I think 2.5 wanted me to now draw the reflecting line of the two graph, which is the graph of y is equals to x, which I've already drawn, which with the dotted lines, right? Now, altogether, so basically this is the concept of what? Of inverse function. Let's just do number 3 now and just remind ourselves whether do we still know how to find the inverse functions after this particular video, right? Now, what will be the inverse function of this? What is this? Remember this. Now, can you see here we are given an inverse? Now we are operating backward, which means now from here we are looking for f of x, right? So which means this is same as the same thing. Remember this was y is equals to negative 2x plus 4. X is equals to negative 2y plus 4. Yes, that's correct. And then now from here, what is that I'm going to do now? I'm going to transpose this one this side, which is x minus 4 is equals to negative 2y, right? Then I'm going to divide by negative 2. I am going to divide by negative 2, right? So which means my f of x in this case will be same as what? X minus 4 over negative 2. Again, so basically now that will be my inverse function, right? So this is just part 1 of the video, right? I don't want to stretch it to be a little bit longer. And now I already know that I've talked a lot, but this was for you to have an understanding of what is inverse. Now, please ensure that you'll watch the second part of this video so that you can have more detailed understanding of what inverse functions are. Thank you very much for listening.